Dear children, today we will discuss Gauss law. You remember, it is the last concept of our first chapter, electric charges and field. You remember, this Gauss law is very important concept in this chapter, and definitely you will get 3 to 5 mark question from this Gauss law. This year also one question has come in CBSE board exam regarding Gauss law. So let us start Gauss law. What is Gauss law? Remember, the electric flux linking with a closed surface is 1 by epsilon 0 times the net charge present within the surface. So repeating again, what is Gauss law? The electric flux, you know what is electric flux? The electric flux linking with a closed surface is 1 by epsilon 0 times the net charge present within the surface. Present within the surface means that is enclosed by the surface. So let us consider it is a closed surface. As it is plane, it is seen as circle, but you consider it is a sphere. So closed surface means which encloses some volume. So you consider it is a spherical surface. Within the surface, a charge Q is enclosed. So what is the electric flux linking with this closed surface? That is, according to the law, it is 1 by epsilon 0 times the net charge present within the surface. That is, phi is equal to Q by epsilon 0. Or as you know, electric flux, that is surface integral of electric field. This indicates that encircle indicates that here we have taken the surface integral over the closed surface. That equal to Q by epsilon 0. It is your Gauss law. So you remember, Gauss law is always applicable to the closed surface. So now, if I will ask, suppose there are two concentric spherical cells. First one has the radius R1, it is related to S1, it is S2, and second spherical surface is S2. The radius is, that is 2R in take. 2R. If you place a charge Q at here, now my question is, what is the ratio of the electric flux linking with these two spherical cells? So you apply Gauss law. For the first cell, you see what is the net charge within this cell, that is Q. So what will be the electric flux? Phi 1 is equal to phi 1 is equal to Q by epsilon 0. Similarly, we want to find what is the electric flux linking with this second spherical cell of radius 2R. You see, you don't think about the radius. We have to see in Gauss law what is the net charge present within the surface, enclosed by the surface. So you see, for the second surface, what is the net charge enclosed? Only you see the charge Q. So electric flux will be Q by epsilon 0. You remember this Gauss law that doesn't depend upon the nature of the surface and the size of the surface. It depends upon what is the net charge enclosed within the surface. So now, what is the ratio? Phi 1 is to phi 2, that is 1 is to 1. If I will place a charge 2q1 here, if the same question is asked, what is the ratio of the electric flux linking with these two spherical cells? For S1, what is the charge enclosed? Q. There is no electric flux linking with S1 due to 2q, because 2q is outside the cell S1. So for S1, the electric flux is q by epsilon 0. But for S2, what is the net charge enclosed? Here it is q, here it is 2q. So net will be q plus 2q, that is 3q by epsilon 0. Then now what is the ratio? That is 1 is to 3. If I will ask one question, another question. Suppose you have a cube of side a each. If you place a charge q at the center of the cube, now my question is, what is the net flux linking with this cube, and what is the electric flux linking with each face of the cube? So you say the net electric flux, very simple, by applying Gauss law. What is the net electric flux linking with this cube? That phi is equal to q by epsilon 0. Now, what is the electric flux linking with each face? This cube, you see, a cube has 6 faces, and as this charge is at the center, all these 6 faces you see are symmetrical with respect to the charge q. So, for 6 faces, the electric flux is q by epsilon 0. For one face, what is the electric flux? That is I by 6, that is q by 6 epsilon 0. In the same way, if I will ask a charge q is placed at the one corner of the cube, what is the electric flux linking with this cube? If the charge q is placed at the center, the net electric flux is q by epsilon 0. Through each face is q by 6 epsilon 0. But if the question is asked, if the charge is placed at one of the corner of the cube, then what is the electric flux linking with the cube? So if consider it is at a cube. If you place a charge at here, then what happens? This charge is not enclosed by this cube. So to enclose this charge, we have to place 4 cube like this in one level, then in one plane. Still you see this charge is not enclosed. So to enclose, another 4 cubes are placed over it. So to enclose this charge, how many cubes are required? That is 1, 2, 3, 4. Again another layer, that is 4 plus 4, 8 cubes. So this charge q at the corner of one cube is enclosed by 8 such cubes. So through 8 cubes, what is the electric flux? That is phi is equal to q by epsilon 0. So through one cube, that is phi dash, that is phi by 8, that is equal to q by 8 epsilon 0. So another important question here we will discuss. You have a cube, you see this figure. You have a cube of side a each, and data given a is equal to 10 centimeter, and this cube is placed as shown in figure at a distance a along x-axis from the center. And electric field E, let it be 2x, and its direction is along x-axis. The question is that what is the electric flux linking with the whole cube? Very important question, you remember. So this type of question this year has come. What is the electric flux linking with the whole cube, and what is the charge enclosed within the cube? So let us start. So electric field direction is along x-axis. You see, this cube has 6 faces. Let the left face is 1. You number the faces. The right face, that is this face C, D, E, H, that is 2. The upper face B, C, H, G, you consider it as 3. And the lower face, you consider it is as 4, that is A, D, E, F. And that face behind, that is A, B, C, D, let it be 5. And the outer face, that is G, H, E, F, let it be 6. So you see, for third, 4, 5, 6, S3, S4, S5 and S6, through these 4 faces, what is the angle between electric field and area vector? Who can say? What is the angle between electric field and area vector? Let me clarify. For third face, you see the direction of electric field is this one because it is along x-axis, and area vector is this one. What is the angle? 90. For this face, A, D, E, F, electric field this one, area vector this one. What is the angle? 90. Similarly, for B, C, D, A, that is for S4 we have taken, S5 we have taken. Electric field is towards right, and that is along x-axis, and the area vector is into the plane. So what is the angle? 90. Similarly for S6, G, H, E, F, electric field is towards right, that is along x-axis, and area vector is outward. What is the angle? 90. So for these 4 faces, the electric field and area vector are perpendicular to each other. Then what is the flux? For all the faces, but that is 3, 4, 5, 6, the angle is 90 degree between E vector and S vector. So electric flux is 0. So now come to what is the electric flux linking with first phase and second phase. For first phase, let it be phi 1. Electric field is towards right and area vector is towards left. That is E vector dot S vector, that is ES cos 180 degree, because electric field is towards right and area vector is towards left. That equal to minus ES. So what is E here? Electric field for this phase, and as electric field depends upon X, so what is the value of the X at here? That is X is A. That is, and you see, you put A in place of X, so E is equal to 2A minus 2A. And what is this area? For a cube, each face is a square, as one face is A, side is A, then as each side is A, then face area is A square. That is minus 2A square. Similarly, for second phase, I2, that is E vector dot S vector, for this phase, you see, electric field is towards right, also area vector is towards right. But here, electric field is towards right, but area vector is towards left. So here, same direction for second phase, that is ES cos 0 degree, that is ES. What is E? 2 into X. What is the X for this phase? It is A, that is 2A. That is, in place of X, you write 2A. What is area? Area is A square, this phase area. that equal to 4a cube. 4a cube. Here also a square into a, that is minus 2a cube. So now come to what are the net flux, that is phi 1 plus phi 2, that equal to 4a, that is for phi 1 it is minus 2a cube, for phi 2 it is 4a cube, that is equal to 2a cube. Therefore you got phi is equal to 2a cube, and in place of a, as we have taken a is equal to 10 centimeter, as a is equal to 10 centimeter, that equal to 0.1 means 10 to the power minus 1 meter. So 10 to the minus 1 into 3, 10 to the minus 1 to the power 3, that equal to 2 into 10 to the power minus 3. What will be unit? As we have taken SI unit, then it is Newton meter square Coulomb inverse. Here we have taken E is equal to 2x, that is in SI system. SI system. So now we got the electric flux linking with the whole cube. What is the charge enclosed by the cube? You put Gauss law, phi is equal to q by epsilon 0. Q is equal to epsilon 0 into phi. What is epsilon 0? You know, 8.854 into 10 to the power minus 12, and phi you got 2 into 10 to the power minus 3. You will solve it. It is nearly 17 into 10 to the power minus 15. What will be the unit? Charge it is, so the unit is Coulomb. So it is your Gauss law. So next we have to learn applications of Gauss law.